Hey guys, this video is over winds. Make sure you take your C notes. There's a lot of information in here. You're going to have a lot of writing, so make sure you pause and take a break when you need to write things down. All right, let's get started. The Earth's atmosphere is composed of four layers. There's the thermosphere, the mesosphere, the stratosphere, and the troposphere. So here is a diagram that shows them. The thermosphere is the closest. We also have the exosphere, but that is just the layer of the atmosphere where we exit our atmosphere. And then here's the thermosphere. Here's the mesopause with the mesosphere. The stratopause is where the stratosphere and the mesosphere meet, and the tropopause is where the troposphere and the stratosphere meet. Now, if you notice when we look at temperatures, they increase and decrease depending on which layer you're in. So the troposphere, you actually decrease in temperature as you get further away from the Earth. And the stratosphere, you will actually increase in temperature. Okay, it goes all the way back up to about negative 20 degrees. And the mesosphere, you decrease in temperature again. And then up through the thermosphere, you're going to increase in temperature again. And then once you get into the exosphere, it does a variety of temperature things up there, depending on where you are and how much solar energy you're getting. The Earth's weather takes place in the lowest level called the troposphere. So it's from Earth's surface to about 20 kilometers up. So how do winds develop? Our winds develop in differences in pressure. Remember we talked about with heat transfer that the sun's heat energy drives all of our winds. And it does. The air rises over warm areas and sinks over cold. Okay, so as the sun's energy comes towards the earth, remember that our earth is going to absorb about 50% of that energy and use that to warm the earth's surface. As we get closer to the equator, it is going to absorb more, because remember when we talked about seasons and rotation, that the equator from the Tropic of Cancer to the Tropic of Capricorn receive the most direct rays. So that's going to heat up the most, and heat from that section is going to warm the air, which is then going to cause it to rise, which is going to cause it to come over, and when it gets closer to the poles, it's going to cool off because that part of the Earth hasn't been warmed as much, and it's going to sink, and then it's going to travel back down towards the equator. So you can see how this convection current works. Heating the air actually decreases pressure. So that means that the molecules are further apart during air that is hot. So the warm air will rise in warm regions where the pressure is low. Remember, that's convection. Example of that is the tropics. Then the cold air will rush in to replace that warm air, and that will increase the pressure. Air descends in cold areas where the pressure is high. We call that subsidence. Okay, so a lot happens in this. So just remember that when the warm air is that low pressure and that air rises, that cold air, which is a higher pressure, is going to rush in to take its place. So air blows from areas of high pressure to areas of low pressure. So here's a convection cell or a room. You have a fire over here and you have cold air outside. So the air is going to rise where the fire is, and then that cold air under the door is going to sink. The cold air from under the door is going to come back in and try to take its place. So you have a higher pressure here. That's why you get that cold draft to that lower pressure there. You need to draw this relationship between air pressure and density. Okay, so here you have warm, lower pressure has less dense air. Cold, higher pressure has more dense air. And if you look at it on a graph, it would look like this. Okay, the higher the temperature gets, the less dense the air is. So do winds go straight from north to south? No, they do not. The rotation of the earth causes the winds to curve. Okay, we call this the Coriolis effect. It's caused by the rotation of Earth. So objects deflect to the right in the northern hemisphere, and they deflect to the left in the southern hemisphere. The apparent deflection of moving objects relative to the observer on Earth. So winds deflect. Winds do not blow directly from high to low pressure. They do get deflected by the Coriolis effect. So if you had a person standing here where A is, and they threw a ball to the person where B is, this is where the person would actually be when the ball reached the edge, because the Earth is rotating this way. So how are winds named? All winds have their name, and they're named by the direction from which they come. So a northeast wind comes from the northeast. A southeast wind comes from the southeast. We have lots of different types of wind. We have global wind patterns and we have local wind patterns. Our global wind patterns travel across the entire globe. They include the doldrums, the trade winds, the prevailing westerlies, and the polar easterlies. Local winds are only affected in certain areas. These are sea breezes and land breezes. So your global winds, this is wind in movement of air from regions of high pressure to regions of low pressure. And you may want to draw this. You don't have to obviously draw the continents around it, but you need to know where they're at. So in the doldrums, which is around the equator, these are areas of low pressure, and this never really changes because the equator receives the most direct sunlight all year long. It is always low pressure. We have northeast trade winds and southeast trade winds, because the area of high pressure here in the horse latitudes are going to rush towards the doldrums. But then they will get heated and they will rise, so then this high pressure will have to keep coming in here. So from 0 to 30 degrees, you're going to have these southeast and northeast trade winds. Then you have southwesterly winds and northwesterly winds. Okay, these are going to be from your 30 to about your 60 degrees. And then you have your polar easterlies on both poles. Okay, so this is an area of high pressure, and this is more of an area of low pressure, so it's going to come from here to here. Your doldrums are a region of low pressure near the equator, usually no winds with clouds or rain. The sun heats the air, causing it to rise, so there aren't very many winds because all the air is going up. The air will then cool and sink, causing it to rain. This is why it rains there a lot. Your trade winds, as air from the equator is warmed so it rises, then air quickly, or actually gradually. Here are your trade winds. Air from the equator is warmed so it rises. It then cools gradually and sinks back towards the doldrums. The Coriolis effect causes these winds to move west. Your prevailing westerlies, the Earth's rotation deflect air from west to east as it moves towards the poles, and westerlies affect much of the weather in the United States. So if you notice that our weather generally always comes from California, that's because we have these prevailing westerlies blowing our wind from that direction. Your polar easterlies, this is very dense air, sinks and then moves away from the poles. The Earth's rotation deflects these from east to west. That's why they're called easterlies. Okay, so here's that picture again. Remember, here's where we lie. Most of our weather comes from these right here. Okay, so is air rising or sinking at the equator? Well, we know that it is rising because it's hot. Is air rising or sinking at 30 degrees? So that's going to be here. Okay. We know that it's going to be sinking, okay, because the air is going to rise here and it's going to sink here. So your local winds. Your sea breeze happens. We're pretty used to this since we are near the sea. We get a lot of these type of wind systems. And during the day, solar radiation warms the land more than the water. So the heated air is less dense and has lower pressure, and the cooler air is more dense and flows towards the warm air. So the breeze comes from the sea to the land, because your air here over land is going to warm, and then the air from the sea is going to rush in and try to take its place, and then it'll get warmed, and that circular motion will happen. So your land breeze happens at night, and it's the reverse. The land cools off much faster than the water does. So that cooler, denser air moves from the warm. So your land is actually going to be cooler. So it's going to go towards the warmer water, which is going to rise and travel back towards the land, and you'll have the reverse effect. So that's the end. If you have any questions, please feel free to ask, and I'll see you guys in class.